Okay, everybody. So lots of graphing. So I'm just going to leave my grid up and hopefully they'll look similar enough to what you guys did. And notice the exactness is not going to be super important. Number one, we're just going to start right along here with number one, which is a quadratic. And what's happened to our quadratic is there is a dilation. So it's going to be thinner. The normal parabola goes up 1 over 1 and then over 2 up 4. So now it's going to be even steeper. So instead of over 1 up 1, it's going to go over 1 up 2. Okay? So it's the normal quadratic except super steep. Right 3 and down 3. So 1, 2, 3, 1, 2, 3, and then over 1 up 2, over 2. Instead of up 4, it'll be up 8. So 4, 5, 6, 7. So it'll look something like that. Now I went ahead, I'm trying to be a little more careful than I normally would. This is kind of hard. Okay. But honestly, you know, if you just made it steeper and you just did a sketch, you don't really need all those points that I did. Okay? All right, the next one is another quadratic, and it's been shifted right 4 and down 2. So 1, 2, 3, 4, 1, 2. And is it negative or positive? Okay, it's positive, so it's still facing up. And so it should, your number 2 should look something like that. Okay? Number 3 is absolute value, and I'm actually going to graph it on the same space because it will fit. Number 3 is moved left 1 and down 4, and it's absolute value. So that has a slope of 1. So that should be your number 3. So there's numbers 2 and 3. Number 4, it's probably not going to fit. So let me erase part of that here. Okay, for number 4, it's absolute value. Move to the right 1. Okay, but it's got a vertical stretch of 2 on it. So instead of just over 1, up 1, blah, 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 it's actually going to be over 1, up 2. Over 1, up 2. So it's going to be it's a steeper absolute value graph. So something like that. Okay, so that would be number 4. Okay, hopefully the first page was not too bad, right? Let's move on to some of the trickier functions. So we're going to go to number 5 next. Now 5 is a cubed root graph. So if you want to start with, you know, the basic parent of a cubed root looks something like this. And really, I only kind of keep in mind that it goes through these 2 points, 1, 1, and -1, -1. And then I just know it's pretty thin the rest of the way. From there, let's see. There's a +1 in the front, but that's the same as a +1 in the back. So this is going to go right 3 and up 1. So that'll be the center. And then those will be my points that are 1 away. And it'll look something like that. So let me erase the original. It'll look something like that, guys. Boys and girls. Okay, so that was number what? 5. Okay, number 6 is a normal square root, and the only thing that's been done to this square root function is the square root of x plus 4, so it's just going to be left 4. No reflections, no anything else tricky, and it's going to look something like that. That's number 6. Number 7 is where it gets, for most of you, not so fun. Okay, number 7 is exponential. And since the number is a 2 to the x, it's going to be an exponential growth. Now, I'll go ahead and just have the parent here just to reference it. There is an asymptote there, and the parent looks something like that. Okay, now, there's a 4 in the front, which means this is now going to be stretched so much that it crosses at 4. Then there's a +1 in the exponent, which is left 1, and then there's a down 1. So this needs to go left 1 and down 1, and then I'm just going to recopy that same shape, okay? So it's going to be something like that. So the final answer would be that one, okay? That would be my number 7. Notice no exact points other than moving the one that was on the y-axis. That's perfectly fine. Number 8. Also exponential, but since it's 1/2, this is going to start as a decay function. That is the worst decay graph ever, but something like that. Now there's a 3 in the front, so now it's going to be stretched to where it crosses at 3 instead. And I'm going to erase the old one as I go. So there's the stretch. There's a -2 in the exponent, so that would be a right 2, and then there's an up 2. So I'm just going to take this point and go right 2 and up 2, and then try to resketch this same picture. Now, does the asymptote move in this one? Yes, the asymptote does move because it's an up 2. So I do need to resketch this asymptote. In fact, in the last one, the asymptote should have been at -1. I know I did not draw that new asymptote in, but it definitely was there. So this one will be this same graph. But once you move the asymptote up, see how it makes it easier to recopy the old one? So graph that new asymptote, and then that's going to help. Okay, now let me undo all of this madness because now we get to do logarithms. Fun. Okay, with logarithms, both of them don't have a base written, so they're both base 10. So like the first one, just sort of imagine, okay, so it's bigger than 1, so it's a logarithmic growth. So it's going to start something like that, just a really steep log graph. Okay, and now we can do whatever. In the parentheses is a +1, and out of the parentheses +1. So left 1, up 1. So on this one, if you move left or right, the asymptote will move. So since the asymptote was at 0, it's also going to shoot back 1. And left 1, up 1. So recopy that curve through that new point now. All right, so that should be whatever, what number was this? Number 9, okay? And then number 10, same idea, except it's a -1 here, and it's a +5. Nope, it's not. It's a -5 out there. So I'm going to take the same parent I had before, and now your asymptote is moving right 1 instead of left 1, so it'll be here. And that point that was at 1, 0, also moves right 1 and then down 5. 1, 2, 3, 4, 5. So the shape that we had gets transposed down here, or transferred, whatever the word might be, and it should look something like that, okay? Steepness, I don't know. We do the best that we can. 10's a pretty big number, so this should have been pretty flat or pretty steep, however you want to think about that. And that should be that. So these are kind of hard to explain without drawing all over the place with a million colors, but that was just your key, and we can talk more about it in tutoring. I hope y'all did okay.